Welcome back to another exciting episode. Today we will go deep into the fascinating world of Titanic survival prediction. In this video, we will uncover the hidden secrets within our remarkable dataset. You can see a detailed dataset containing valuable information about the passengers aboard the Titanic. This dataset includes features such as passenger class, age, gender, family relation, ticket fare, and even the cabin they were assigned. By analyzing this data, we will strive to uncover patterns and insight that can help us predict the likelihood of survival for each passenger. Without further ado, let's jump right into the code and start our exploration. The dataset we will be working with is compressed in a zip format. To access the valuable information within, we will need to unzip it first. You can find the dataset link in the description below. Now, it's time to import the essential libraries we will be using. First up, we need the Pandas library. Pandas is the go-to library for data manipulation and analysis in Python. Next, we will bring in another crucial library, Scikit-learn. This library provides a wealth of tools for machine learning. Now that we have our essential libraries imported, it's time to load the Titanic dataset. The dataset we will be working with is in CSV format. Let's start by reading the CSV file and storing it in a variable called data. We will be using read CSV function from Pandas. To get a quick glimpse of dataset, structure and content, we can use the head function in Pandas. This function displays the first few rows of the dataset. There it is. We can see a snapshot of the dataset showcasing the different columns and the information they hold. This allows us to gain an initial understanding of the dataset structure and type of data we will be working with. Now it's time to perform data normalization. First, we need to select the features that we believe are relevant for prediction survival. In this case, we will focus on the passenger class, gender, number of siblings aboard, and number of parents aboard. To create our feature matrix, we will use the getDummies function from Pandas. This function will convert categorical variables into numerical representation. Next, we define our target variable, which is the survived column from the dataset. This column represents whether a passenger survived or not. To achieve maximum absolute scaling, we will create a new copy of our feature matrix called datascaled. This copy will preserve our original feature while applying the scaled transformation. We iterate through each column of datascaled and apply the scaling formula. This formula subtracts the mean of each column from its value and then divides by the standard deviation. Scaling ensures that no single feature dominates the others, giving each feature an equal opportunity to contribute to the prediction. Now it's time to split our data. We will be using train test split method to split our data into train set and testing set, in which we will use training size is equal to 0.80, which ensures that we will be using 80% as a train set. To keep track of their performance, we will be adding each model's name to the models list and their corresponding accuracies to the accuracies list. We will be using the power of 4 machine learning models: random forest, KNN, logistic regression, and SVM. Each model brings its unique strength to the table. We will thoroughly explore their potential by training and evaluating them on our preprocessed dataset. Let's begin with logistic regression. With logistic regression imported from Scikit-learn, we initialize our model. store our model's name. Then we fit our model to the training data. After that, we make predictions on the testing set. In the end, we calculate the accuracy and store the result in the accuracy list. We then display the accuracy of the model. Now it's time to implement random forest. With the random forest classifier imported from Scikit-learn, we have initialized our model with 100 decision trees, a maximum depth of 5, and a random state of 1 for reproducibility. We then store our model's name. We fit our random forest model to the training data. Make prediction on the testing set. And after that, calculate the accuracy and store the result in the accuracy list. We then display the accuracy of the model. Now let's do with KNN. With the KNN imported from the Scikit-learn, we initialize our model with 5 neighbors and do all the previous model steps with respect to KNN. Now let's implement our last model, that is SVM. With the SVM imported from Scikit-learn, we initialize our model and do all the previous model steps with respect to SVM. To create the bar plot, we will use matplotlib. To visualize our data with elegancy and clarity, with accuracies on the y-axis and model's name on the x-axis, we will paint a vivid picture of how each model performed in the Titanic survival prediction challenge. And with that, our captivating journey through the Titanic survival prediction has come to an end. Don't forget to hit that subscribe button and click the notification bell to join us on our future data projects.